morning, everyone. Glad to have this opportunity to talk to everyone. As was mentioned, I am a professional geologist. I am licensed to practice in the Commonwealth of Pennsylvania. I do work for Moody & Associates, and just one correction. Actually, the regional office that I head is actually in Tioga County, New York, in Waverly, although I can see Pennsylvania from my office window. We were formerly in Sayre when we first set up the office, and as our office got larger and larger, this was not a strategic move. We're not attracted to the tax rate of New York State or anything. It just so happens that the building we needed was on the other side of the border. We are now located in Waverly, New York. Moody & Associates, just so you guys get some sort of perspective of why you should even be listening to me, watching, believe anything I say. We are a groundwater consulting firm. We've been drilling water wells since 1891. Mainly we focus now on municipal, industrial, and commercial wells. And we have a very, very large presence in the upstate New York communities in servicing their wells. Pump replacement, well rehab, drilling new wells, development of water well fields. So this is our area of expertise. I've been asked to come here to speak on the hydraulic fracturing process and how it relates to drinking water sources from a potential pollution perspective. There's a lot of things to talk about, right, when you're talking about the Marcellus Shale. This particular topic, hydraulic fracturing and drinking water quality, is a pretty hot button issue. It's an emotional subject. Anyone getting angry yet already just thinking about it? Everyone's calm. I should probably state it right now. I am not pro-hydraulic fracturing, and I am not anti-hydraulic fracturing. I am pro-science. And it's something I do as a profession, something I take very seriously, and I don't just pay lip service to the term, go where the science takes us. So what I wanted to talk about in this particular presentation, I kind of broke it up into 4 categories. One, just a primer on what is hydraulic fracturing. And if you understand that, I apologize. You've got to listen to me babble for 20 minutes or so on it. But I think it's important to cover because I don't think people understand what it is. If people understood what hydraulic fracturing is, maybe we wouldn't be having so many of these conversations still. So I thought it was important to cover. Then a second topic I wanted to cover was the protection of groundwater in Pennsylvania. What can we expect with a typical Pennsylvania groundwater? What's it like? What's the Commonwealth doing to protect that quality of water, especially as it relates to oil and gas development? The third topic was, okay, are there groundwater quality impacts in Pennsylvania? It's probably why everyone's here. So I'll make you wait until close to the end. And then the last one I want to talk about is lessons learned. As an industry, especially the Marcellus Shale, things grew up quickly, and we've learned a lot in the last 3 years. So I just wanted to explain to you people, some of the lessons that we've learned, some of the things that we're doing better that we maybe necessarily weren't doing 3 years ago. And when I say lessons learned, we're always talking from the perspective of environmental protection. How can we improve that? How can we do it better? How can we make sure everyone stays safe? What is hydraulic fracturing? It's a brand new controversial industrial activity, right? As this rig from 1950 tells us. So it's not necessarily a new process. So what is hydraulic fracturing not? I think it's important to separate the different processes of drilling and constructing a gas well. And I'll leave the construction stuff to John because that's what he does for a living. But it is not necessarily it's not part of the drilling process. It's a completions process that's done after drilling is completed. It's a poor choice of words, but I'm sure you understand what I meant. As far as what is drilling a gas well, I think everyone knows now that The conventional well is a vertical well. It goes straight down into the ground. The drilling of natural gas wells has been ongoing since the early 1800s. You'll be cheating if you look at my slide, but anyone want to guess where the very first gas well was drilled? Right in New York State. William Hart, Fredonia, New York, in Chautauqua County. And about 40 years after that, the first oil well was drilled in Oil City, Pennsylvania, which is Venango County, which is the part of the world I'm originally from, northwest Pennsylvania. And that first oil well was 69.5 feet deep and completed in a sandstone formation. A horizontal well, which is what we're talking about with the Marcellus Shale. Some background on that. Directional drilling was developed plus or minus 1929, so that's not really a new process either. But what is new is that in the last decade or so, it's become more attractive technically and economically. It's become more feasible. So what's the difference between vertical and horizontal drilling? A vertical well, the drawback of a vertical well is that you're only exposed to that vertical thickness of your target formation. If the Marcellus Shale is, say, 50 feet thick, you drill a hole through it, the only exposure you have to it is that 50 feet. Whereas a horizontal well can extend laterally, over a mile, 7,000 plus or minus, 8,000 plus or minus feet. So if you say the average thickness of the Marcellus is 100 feet even, you'd have to drill 70 vertical wells to equal the productivity of one horizontal well. If the producing area of the Marcellus is only 50 feet thick, then you have to drill 140 wells, vertical wells to equal the productivity of one vertical well. To demonstrate a little bit of that, this is some vertical well drilling in northwest Pennsylvania. This is a Google Earth image. This is from the air. And can everyone see these? Can everyone see the 1,000-hole golf course? Which is what it looks like to me. Now we are comparing kind of apples to oranges here, but these are all vertical wells. Imagine if we could only drill 1/70th of those. How much better would this look? Or 1/100th of the number of these wells using horizontal drilling technology. And once again, the advantages of horizontal drilling, greater wellbore exposure, maybe even more important, the surface impact is smaller. Like I said, we're dealing with a fraction of the number of the acreage of surface water that we need to, or surface area that we need to disturb to get what we want to under our feet. And it does provide some access to resources under existing infrastructure, or buildings, or environmentally sensitive areas that we couldn't otherwise get with. We can't set up a well pad and drill a vertical well in the middle of a swamp or a wetland or a high value or exceptional quality stream, right? So, what is the hydraulic fracturing part of this? It's a process that allows for stimulation of the well, and John will correct me when he does his presentation where I screw up here. And it injects fluid, which consists of water, sand, and additives under pressure to crack a specific thickness of that target rock. It places sand grains into the resultant cracks to hold them open so we can get flow into the wellbore. And hydraulic fracturing is based on the rock mechanics of the formation to stay in that target formation. There is no economic benefit for those fractures to go outside of the target formation. And I'll talk about those fractures in a little bit also. The first commercial application occurred in the late 1940s of hydraulic fracturing. And we keep referring to it as a brand new technology, and it's not. It's been ongoing in New York State for about 50 years now. I don't know if they're fracking the well today, but if you have a Trenton Black River well or an Oriskany well, that's vertical in New York State, it's been hydraulically fractured. It's now a routine technology. It's been used on approximately 1 million wells throughout the country to stimulate both oil and gas production. We now hydraulically fracture as many as 35 new vertical and horizontal wells a year. And it's completed in non-shale bedrock in New York State all the time. Wells are permitted, drilled, and hydraulically fractured in New York State all the time as we speak. What we're not hydraulically fracturing is the high volume, where we need high volume of water in the shale place, like say the Marcellus Shale. That's what the moratorium is on. This is a little bit of a cartoon. This whole process has been updated since this cartoon was originally depicted. Most specifically, ignore the pit up here. Those really don't exist anymore, and I'll talk about that a little bit later on. But these are the hydraulic fractures in the horizontal portion of the well. These wells, and this is kind of an exaggerated cartoon of that. And when we're talking about these fractures, sometimes we get the impression that these are, huge voids in the rock, 10 feet wide. That's not what they are. These fractures are typically the width of my hair. They're held open with grains of sand, and some of them are even microscopic. And as demonstrated, sort of, in this previous slide, those fractures do stay, or they're designed to stay, in the target formation. Like I said, there's no economic benefit of those going outside of the formation. So what is frac fluid? I hate using the word frac. What is hydraulic fracturing fluid? I think everyone's heard most of these statistics. It's plus or minus 99% water. It's a 0.5% sand or some other ceramic proppant. And the remaining 0.5% is that other stuff that we're worried about, right? That's what everyone wants to get to the bottom to. And that other stuff, why do we even have to have that other stuff? The reason we have to add those other stuff are multi. Some of it's an acid to help start dissolving the rock so we can start the fracture process. Some of it is for biocides to keep, to stunt the growth of bacteria in the well that could foul the well. Corrosion inhibitors to keep the pipes, the casings from corroding. Friction reducers, if anyone's ever heard the word slick water, that's what we're talking about. The easier we can get it in, the less pressure that has to be used, and the easier and quicker the whole process is. Can I go to Lowe's and buy a bottle of frac fluid? Has anyone ever tried that? Ever had it on sale? To my knowledge, you can't. The ingredients are mixed on the well pad and injected into the stream as part of the completions process. One thing I always hear, a concern of a lot of people is, well, we don't know exactly what they're using in these Marcellus wells. We don't know exactly the chemicals being used. There's a website called FracFocus, FracFocus.org. You can go on this website, locate any Marcellus well in Pennsylvania you want, and get this. What this is the chemicals used in the frac job of a particular well. I picked one at random. I just picked one that was in Susquehanna County, as close to the border with Broome County as possible. To give you some perspective, because there's nothing magical about that state border. The geology doesn't change all of a sudden on the other side of it. So this tells you what's in that hydraulic fracturing fluid. Now, oftentimes you'll see something, and you probably can't see it. Down here, the purpose of the chemical used is for clay control. And over here, it'll say proprietary. That makes a lot of people nervous, and probably rightfully so. But, and I'll explain this a little bit later, you don't need to necessarily know that they're using methyl ethyl death or 1,3,5 trichloral baby killer in their, and not that they do that, but you don't need to know exactly what's in there to protect yourself from it. And I'll explain some of that later on. So if we go back to this is an aerial view. And for those who don't know, this is in the Allegheny National Forest. And I believe this is McKean County, Pennsylvania. The reason I bring this up so much is that the Allegheny National Forest is a second home to my wife and I. I spend a lot of time camping, backpacking, and hiking in there. In fact, last spring, I just completed the North Country Trail, all 110 miles of it through the National Forest in 9 days. Killed me, but the job got done. So I'm kind of familiar from actually walking up and looking at these things. And these are all vertical wells, like I said earlier, but anyone want to hazard a guess on how deep they are? These are wells that generally produce oil, but a certain percentage of them also produce oil and natural gas. These wells are anywhere from 1,600 to 2,000 feet deep, and we still drill them every day. The reason we can't apply the horizontal drilling technology to these particular wells is one, depth. I don't think there's enough room to get hit on it. But we're also targeting multiple formations that are very thin, 10, 20 feet wide. For example, the Bradford oil sands, the Chipmunk sand, the Cane sand. We would target, when I say we, not me, but the gas industry. So there's multiple formations in there that we're targeting. And these wells are fracked all the time in the Allegheny National Forest with single casing construction. Anyone want to take a hazard at the depth of how shallow that frack can occur on these wells? Some of these gas-bearing formations are within 500 feet of the surface, and we frack them. And to date, we have not had a problem that I know of, both from a literature research and the fact that I walk up and drink the water in a national forest when I'm backpacking, because I can't carry 16 gallons of water with me when I start. I'm filtering these surface water sources and using them to drink while I'm hiking and backpacking through the national forest. So I can see how this gets personal for a lot of people, because it's personal for me. I still want to be able to enjoy these areas too. So Pennsylvania groundwater, what is it? How do we protect it in Pennsylvania? And like I said, this is coming from the perspective of water well drillers. This is what we do for a living. This is one of our old air rotary rigs, and where I'll leave that is it was quite a rig in its day. And this is actually a flowing well that we located for a municipal well field. So we understand groundwater, we understand how it flows, we understand how well construction affects both the quality and the quantity of the water coming out of that well. So Pennsylvania does not regulate private water sources for well quality or well construction. Nothing. Zero. Pennsylvania is land of the free, home of the brave. If you drill a well, you want to drink the water, God bless you. No one in Pennsylvania is going to tell you that you cannot do that. For perspective, there's one other state in the nation that does that, and that's Alaska. To me, that's perspective. As opposed to New York has minimal regulation. Your county health departments will want to do their due diligence on the siting of that well, make sure it's not downgrading of your septic system. There's certain setback distances, etc. But that's about all that New York State does to regulate groundwater wells. Pennsylvania has a lot of private water wells. Best estimate, it's the second most private water wells of any state in the nation except for Michigan, which also has a pretty rich oil and gas development legacy. And up to 20,000 new private wells are being drilled every year in the Commonwealth of Pennsylvania. So there's a lot of wells, and there's no regulation of their construction or the quality of water coming out of them. So where does that get us? Sometimes cheaper is better, right? You know, we get into some questionable wellhead protection practices in Pennsylvania. This one here, this is what's called a split well seal. And this commonly happens with them as they age. Someone pops it off and they can't get it back on. So it's just exposing the wellhead to the atmosphere, and what may happen, may happen. Here we have an artesian well with a hydrant on top of it, also exposed. This area right here is exposed to the atmosphere. Not good. Here we have a well in someone's basement. This is extremely common in Pennsylvania, where the well will be in the basement of the house. I don't know how common it is in New York, but in Pennsylvania it's very, very common. And we run into ugly situations like this. For those who can't tell, this is the well right here. Anyone see any problems with wellhead security here? You know, I see these metal cans, I'm thinking benzene, toluene, degreasers, TCE. They were kind enough to spray their wellhead with VOCs, you know, light paint. And my question is, when I walk in a situation like this, is why is the T-bar permanently attached to your pitless adapter? Why do you have to pull your pump so much? What's going on? So that's a bad situation. Here, this is not staged. I promise you this is not staged. We've done a lot of pre-drill water supply sampling in Pennsylvania. Like I said, a lot of unregulated sources. This is one where the line between a spring and a dug well is often blurred. What one calls a spring, another calls a dug well. This was a well house, for lack of a better word, and our technician opened the door, and this is what he saw, and snapped a picture of it. I cannot explain the sequence of events that led to this particular happening being here, other than I just see the result of it. You wouldn't do that to your well, would you? Right? Hang animal parts down the top of it. Here's another one, another dug well. Here's the extent of the wellhead construction. This piece of plywood that lays over top of it. We have seen the darndest things of water sources that people drink from on a daily basis. It's not good, it's not bad, it's just the way it is. And often, you ever see those cheap plastic or aluminum well caps where the screws go on the side? It doesn't really seal the wellhead, bugs can still get in it, and whatever. I always tell people, if they've never taken that off, don't. Just remain blissfully ignorant. You don't want to know what's on the underside of that well cap. Just leave it. And to back up a little bit, where we often will run into trouble, and this is a presentation I'd love to spend about 16 hours on, is this annular space here where the casing goes through the ground, the space between the casing and the borehole. Since there is no regulation in Pennsylvania, most people try to save money by not grouting in that annular space. They just shovel the cuttings back in, that came up during the drilling process. And that's all there is, which is a potential conduit for contaminants from the surface that trickle down the side of the wellbore and get into their water supply. Boy, some number greater than 95% of Pennsylvania private water wells are constructed exactly like that. And where this really becomes a big issue is flooding. The Twin Tiers have had multiple large-scale events of floods in the last couple of years. And when you have a construction like that, flood water can also often follow that potential pathway, which is why that's a bit of an issue. Anyone hungry? So what kind of quality can we expect from Pennsylvania groundwater? And I'm going to cite some statistics that were largely gathered, or entirely gathered, before the onset of large-scale Marcellus development in Pennsylvania. At least 40% of private water wells in Pennsylvania failed at least one Safe Drinking Water Act water quality standard just naturally. And the Safe Drinking Water Act does not apply to private water sources, certainly at least not in Pennsylvania, nor does it in New York. But we have to have some sort of numbers to compare this to. And if you're developing a municipal water source, you absolutely have to follow the Safe Drinking Water Act MCLs. But the most common natural contaminants, for lack of a better word, that we see in Pennsylvania water wells is coliform bacteria. And a lot of that has to do with the well construction and wellhead security, like I just discussed. A lot of iron in Pennsylvania groundwater, a lot of manganese. Another parameter that often fails is turbidity. And turbidity is the cloudiness of the water, either caused by sediment or bacteria or some other source. Methane was present in at least 20% of wells. There's some dispute into this number of 20%. I suspect it's actually larger, but that has to do more with analytical methods, laboratory reporting limits. That number depends on what your reporting limit or your method detection limit is for methane, and that's another 18-hour presentation. Maybe I'll come back to do someday. But most of the wells in north central Pennsylvania are completed in the Lock Haven, what's known as the Lock Haven Formation, and I believe in Pennsylvania that's part of the Canada Lake group. I think in New York. And methane in the Lock Haven Formation has been documented in many geologic publications from the Pennsylvania Geologic Survey that predate shale gas development. In fact, it's referenced as early as the late 1800s and early 1900s as being just naturally in the aquifer. Well, why? And the next slide's my favorite, because this is why geologists are cool. The reason is that in the Appalachian Plateau physiographic province, the Lock Haven Formation is the only dominant formation below the drainage level that is marine in origin. Thusly, the nearly flat-lying strata have not been completely leached of its connate water like its folded counterparts in the Valley and Ridge province further south. In some locales, the strata have only been partially flushed with meteoritic water so that salt water is encountered below beds containing fresh water. What the hell is that? What that means is in north central Pennsylvania, and this also applies to most of upstate New York, we have what's called layer cake geology, right? The formations are relatively flat-lying. There's very little structure to them, very little bends like you would get when you start going south of Williamsport, Lycoming area, Philadelphia. So, it still has all that salt water from its environment of deposition, from those ocean sediments. And that's what they mean by connate water, the water of formation. It's still there after hundreds of millions of years. Because it's flat, it hasn't been able to be flushed out with fresh water from the surface yet. So what we end up with is pockets that still contain hydrogen sulfide, briny water, chlorides, and methane. So and these are just two references I had handy to my desk when I was preparing this. That Lohmann reported in 1967 that a few aquifers contain natural gas which can be ignited as it bubbles from the water. This is in the Lock Haven, where most of the water wells are drilled. And Williams in 1998 reported that water wells in the glaciated valleys of Bradford and Cuyahoga counties that penetrate zones containing highly saline groundwater commonly produce hydrogen sulfide and or methane gas. But Lock Haven has so much methane in it in some areas that it has been commercially drilled and produced in the 40s and 50s for natural gas. So how do we protect, knowing all this as our backdrop, how do we protect what we have in Pennsylvania? It all started with the Oil and Gas Act in 1984, which was recently updated in the beginning of 2012, which the passage of House Bill 1950. Most everyone in this room has probably heard it referred to as Act 13. That's usually what it's referred to as in media publications. And Act 13 presumes that an unconventional well operator, what we mean by unconventional is horizontal shale. A water well is located within 2,500 feet of the oil or gas well. the operator is presumed guilty of impacting that well, if there is an impact, and it has occurred within 12 months after the completion or alteration of the unconventional well. Unless pollution existed prior to the drilling or alteration survey as determined by a pre-drilling survey. Pre-drilling survey, in Pennsylvania and New York, that's just part of our language. We understand that. Pre-drilling survey in the world of oil and gas development was a brand new word when most of these people showed up for the Marcellus. Previously worked in Wyoming or Oklahoma or Texas, where we were dealing with a different population density. You can't pre-drill nothing. There's no water wells there because no one lives there. There's nothing to pre-drill. So this was a new experience. So we have a lot of pre-drilling surveys going on, and the results of those, according to the regulation in New York State, have to be sent to the landowner and to the DEP within 10 days of being received. Current regulations in Pennsylvania, promulgated from the Oil and Gas Act, we refer to as Chapter 78. Chapter 78 has not been revised yet to reflect the provisions of Act 13, but that is in process. So we still have to abide by the legislation, even though it's not regulation yet. And how do we conduct these pre-drill surveys? It's what's called chain of custody water testing. That's how people like us tend to get hired sometimes. Because we're trained. We understand water wells. We kind of know what we're looking for. And it's referred to as chain of custody or third-party water testing. And this assures that individuals who handle the sample are documented on the COC, the chain of custody, and that only unbiased professionals using proper sampling protocols have access to the samples. So the landowner can't collect his own pre-drill water sample. His neighbor can, his brother can. An employee of the gas company can't collect it. This is meant to protect everybody, to protect the landowner and to protect the operator. So what exactly do we sample for? Well, that's one of the things that Act 13 doesn't, it simply doesn't cover. It doesn't specify an analyte list for pre-drill sampling. So often what we rely on is what's referred to as the Marcellus Shale Coalition recommended list of pre-drill analytes. And this is what that looks like. We have a lot of general chemistry. We have the dissolved gases, methane, ethane, propane, lots of metals, and for some reason they like to get salts, sodium, chloride, turbidity. Frac fluid is not going to sneak up on your well without us knowing by analyzing for this list of contaminants. And this is what I meant earlier when I said you don't have to know what they're using to protect yourself from what they're using. Methyl ethyl death isn't going to show up in your water well without all this other stuff coming with it. Once we see an increase in this other stuff, if we ever see an increase in it, then we start knowing that we can throw the kitchen sink at the analyte list. We start sampling for EPA methods, 8260, 8270, for volatile organic compounds and semi-volatile organic compounds. And whatever's in there, we're going to find anyway. So I don't think people necessarily have to be as concerned as they sometimes are by not knowing exactly what's in the hydraulic fracturing fluid, even though the industry does a pretty good job of letting everyone know what that is anyway. If you wanted to protect yourself, in my opinion, you need about 5 analytes that you need to sample for. Specific conductance, total dissolved solids, chloride, barium, sodium. To me, that's all you need. Because if you have an impact, we're going to see it in those analytes. Actually, most of the operators sample for an even larger list than this. They fiddle with this list, they add to it. A lot of times you'll see ethylene glycol added, strontium will be added, bromide will be added. So in Pennsylvania, there is a pretty good job of dealing with what analytes to sample for to protect water supplies. Chapter 78 does not address post-drill sampling, which the current version of the Supplemental Generic Environmental Impact Statement for New York does, and John will talk more about that later on. Post-drill sampling is neither specified nor required in the Act or in Chapter 78, and is generally performed by the gas operator following a complaint. And oftentimes we're sent out to deal with a complaint. Is it a real complaint? Was there an impact? Was there not an impact? Where do we go from there? So we do have, I think, there's some holes in it, but the necessary protection of groundwater in Pennsylvania is there. If there's a problem, we're going to see it. So, are there groundwater quality impacts in Pennsylvania? No one get up and leave after you know the answer. You got to stay till the end. Anyone find this picture as fascinating as I do? What are these things sticking up here? This is in Bradford County. This is on Armenia Mountain, in Armenia Township, Bradford. There's a whole bunch of those windmills up there. According to data on the PADEP's website that you can look up yourself, there are nearly 4,000 Marcellus wells that have been drilled in the north central region of Pennsylvania to date. And I refer to the north central region because it's the area that New York State has most in common from a geography and a geologic perspective. So, how many documented cases of hydraulic fracturing fluids moving through the subsurface into groundwater aquifers have occurred in Pennsylvania? We've had 4,000 Marcellus wells drilled. Anyone want to hazard a guess? Does that mean we've had 4,000 impacts? I mean, we've read the newspapers. We've read about the hellfire and pestilence in the industrial wasteland, right? It's a foregone conclusion. Is it 4,000? Is it 100? Is it 10? 0. We've had 0 cases of hydraulic fracturing fluids moving through the subsurface into groundwater aquifers. And there's nothing, no press release from the EPA, United States EPA, that would contradict that number nationwide. In fact, in a study completed in 2011 by the Center for Rural Pennsylvania, a bipartisan legislative agency that serves as a resource for rural policy within the PA General Assembly, it was determined in that study that statistical analysis of post-drilling versus pre-drilling water chemistry did not suggest major influences from gas well drilling or hydraulic fracturing of nearby water wells. They just didn't see it when they empirically compared post-drilling to pre-drilling. So, after nearly 4,000 Marcellus wells drilled in the north central region of Pennsylvania to date, what are we left with? I'm not going to stand up here and tell you that there have not been problems. It's a large-scale process. There's human error, equipment issues, there's equipment failures, there's product failures. There are some things that we need to be cognizant of and address and minimize their occurrence. So what we're left with is what's approximately 3 dozen cases of what's referred to as potential stray gas migration documented by the PADEP in the north central region of Pennsylvania. And that includes, that 3 dozen cases includes confirmed cases, cases currently under study, and cases that have been under study and closed. They've been fixed. So, stray gas, what is that? That sounds pretty scary. Stray gas, or methane, is a term generally used for the migration of methane, or the concentration of methane in the subsurface. Well, how does that happen? It can occur via multiple mechanisms when drilling or constructing a well. And I said drilling a well. I didn't say drilling a gas well. We have done this drilling high-capacity municipal water wells. We've agitated the aquifer, drilling on air, we've pushed methane, and we've concentrated it to where you would temporarily see increased concentrations of methane that some X point away from where we were drilling our water well. And I would not propose that we start a moratorium on drilling water wells because of that. The good news about that, it's temporary. Once the aquifer re-equilibrates, it goes away. It goes back to the way it was before. There can also be, you can introduce a migration or a mechanism when completing a gas well. And it has mostly to do with the integrity of the cement job in the angular spaces of the well. And there's good news about that too. The good news is we can identify that and fix it. Usually by what's referred to as a squeeze, a perfect squeeze, where they find the faulty area, perf it again, and inject cement in there to close that pathway. Be very, very careful here, because some people want to jump to another conclusion when they hear me say that methane can migrate up the side of a pipe in less than ideal conditions. They say, well, why can't hydraulic fracturing fluid do that then too? And the reason that is because you're comparing a lighter than air gas. It does not behave in the subsurface the same way a viscous fluid does. So that's why we can't make that leap, and we also can't make that leap because we haven't documented it happening yet. So what is methane? That's getting a lot of press lately too. Methane, it's CH4, it's the simplest paraffin hydrocarbon gas. It's generated by multiple processes, by both microbial and thermogenic. Microbial methane is created by bacteria that's metabolizing things in their environment, and what they end up with, what they produce is methane gas. That's your swamp gas, your landfill gas. But methane is also created in the geologic context thermogenically. And thermogenic means heat and pressure. We're taking these shales that, has anyone seen the shales in outcrops in New York State or in northern tier of Pennsylvania? What color are they? They're dark, right? They're dark gray, they're black. And that indicates an environment of deposition that's reducing, it's anoxic, it's metalliferous, and those are all perfect conditions. Over time, you bury that rock, you squeeze it, you heat it up a little bit to produce methane gas. And that's what we mean by thermogenic. Methane is flammable, colorless, odorless, and it's got a specific gravity of 0.555, which means it's about half the density of air. So if methane pops up through the floor there, it wants to go to the ceiling, and it will relatively quickly. It's got an explosive range in the atmosphere of 5 to 15%. So if you're at 5% by volume methane in the atmosphere that you're standing in, there is potential for explosion. And that's why we're concerned about methane. It's soluble in water till about 28 milligrams per liter. And it is non-toxic. There's no ingestion hazard from drinking water with methane in it. Our concern is the safety hazard. So, safety. Lower explosion limit, 5% volume, which is equal to 50,000 parts per million. Solubility limit of methane in water, plus or minus 28 milligrams per liter, which is, it's not exactly 1-to-1, but it's roughly equivalent to 28 parts per million. Which is the bigger number, the lower explosion limit or gas, methane off-gassing from water? There's a pretty big safety factor built in here. Even if this number was 100, which can happen dissolved in water for a lot of reasons, which is another graduate level geochemistry course that maybe I'll give someday. What that means is methane off-gassing from your water spout or your water faucet, you almost have to try to blow up a house to do it. And that's not to minimize the impact, because we absolutely make sure that it never even gets to that phase. But there is a large safety factor built in, 28, 50,000. So that's kind of a summary of the impacts to Pennsylvania groundwater. We've had a limited number of stray gas migrations. But like I said, the connection of hydraulic fracturing and that fluid, it's not there. But with that being said, there have some lessons learned that have been learned over the last 4 or 5 years of Marcellus shale gas development in Pennsylvania. It started, Pennsylvania and New York, it's a different regulatory climate than Wyoming or Montana or Texas. It's got different geology. It's got different population geography. We think we're in the middle of nowhere, but we've got a fairly high population density compared to Montana or Wyoming. There's just a lot more people here than there are there. And it's a different socioeconomic climate. The culture's just different here. So with all those things wrapped up together, there have been lots of lessons learned, a lot of positive lessons learned with regard to how the environment is treated. One of the big things is that most operators are now going through a process called the pad location evaluation. How do I know they're doing it? Because oftentimes we do it for them. They're looking at a lot of things. They site a well based on the geophysics, based on the structure, based on what the egghead geologist tells them to put the well, put it here. Okay, if we put it here, what happens? Maybe we need to look at that a little bit closer. So we're looking at, are there already some naturally occurring potential migration pathways? Is the bedrock especially fractured, which is what these red lines on the map are. This is a technique called, that we use to locate water wells. We use stereoscopes, and we look at pictures and they pop up in 3D, and we look for these linear structures on the surface, and if we get two of them intersecting, can we put a water well right there and get a whole lot of water? And that's a process we use to locate high-capacity water wells. However, it could be a potential pathway for stray gas. So if there's a lot of fractures, do you want to put your well pad there? They take a look at wetlands. Are there any high-quality or exceptional value water bodies, surface water bodies? What's the nearest down gradient receptor? Where's the closest water well? Where's the closest human receptor? Where's the closest school? Where's the closest hospital lab? Do we want to be near these things? And there are multiple operators that have made a business decision to not put a well where they originally wanted it, where it would have been ideal, because of these factors. I've seen some operators move their well location 2 or 3 times, taking all of this into account. Flowback pits, big word, right? They are largely not used anymore. That was a lesson learned. Mostly the flowback water is contained in a closed loop. It never sees the light of day. When you see a pit like this nowadays, it's usually got fresh water in it that they haven't used yet. So, we've significantly minimized the use of flowback pits for storing produced waters. Assessment of legacy oil and gas wells. It's not so prevalent in north-central Pennsylvania as much as it is in northwest Pennsylvania, but there are a lot of wells out there that are no longer in production. They were drilled in the 20s or 30s or 40s, back when it was a different time. It was a different culture. They didn't abandon them sometimes. And a lot of these wells are Oriskany wells in north-central Pennsylvania, which drill right through the Marcellus to get to the Oriskany, some 1,500 feet even lower than the Marcellus. Can these be potential pathways, since they're drilled through the methane, to move things by accident? A lot of money, a lot of effort is being put into both regulation and above and beyond by operators to locate these. And I've seen them come in and properly abandon these wells, just to eliminate that potential. Additional lessons learned. The pre-drill radius by Pennsylvania regulation and legislation is 2,500 feet. Most of the major operators go far beyond that. 4,000 feet, 4,500 feet, some have gone as far as a mile, just for the extra protection. They've increased the analyte list, which I've discussed earlier. They've gone beyond the standard industry practice and added more analytes to it. I had mentioned earlier that there's no post-drill sampling required in Pennsylvania. Some operators are now voluntarily doing that. To compare pre-drill versus post-drill, which is another science project, another lecture I'll give another day, taking one point in time, comparing it to another point in time, and the natural variability in that, without even worrying about a potential human impact. But they are voluntarily doing post-drill sampling. There's been development of industry environmental work groups and committees that sit down specifically and say, how can we do this better? How can we better protect the environment? How do I know this is going on? Because I sit on many of these committees and work groups. 36 stray gas incidents and 4,000 gas wells drilled is not an acceptable number to anybody. It is goal zero. What can we do to make sure nothing happens? Nothing's pretty severe anyhow. It's a goal. It's absolutely a goal. They're continually refining well construction and cement practices, developing even more environmental sensitive ways of dealing with produced water, the flowback water. Major way of dealing with that now is recycling it, just taking it from hydraulic fracturing job to hydraulic fracturing job and using it over and over. So there's a lot of positive things that the industry has taken upon itself to improve on. And I guess in closing, I apologize if I went long, I have no idea. I recently last week I had my OSHA 8-hour annual refresher. And the instructor told me that every 13 minutes, somebody in this country dies from an automobile accident. How did everyone get here today? You determined that that was an acceptable risk, even though that's a very large number. What color were the roads that you drove on to get here? What color has your car been since probably December? White. Why is it white? And it makes me wonder how many accidents we have to have with hydraulic fracturing fluid through an accidental spill or something to equal what we do on purpose on a typical winter day in New York State. Something to think about. Thank you, everyone.